Hello students, in this video we will be learning to read the new instrument called Vernier Callipers. You can see, and this instrument had been invented. It was invented by a scientist or a person named as a Pierre Vernier. So from his name we have derived the name of this instrument, which nowadays we know it as a Vernier Callipers. Callipers means jaws, or two calipers over here which you can see. Now what is the use of this instrument? In order to learn to read this, you should know how to read main scale and a vernier scale. So in order to read this instrument known as a Vernier Callipers, you should learn how to read a main scale and vernier scale. It means, what about main scale? Main scale division and vernier scale division. Now let me just give you one simple example. If I'm going to draw point A and point B, and I'm going to ask you, how can you measure the distance between these two dots? So which instrument will you use? Will you use this simple scale, a normal scale? So what you can say, to measure the distance, I'm going to use the scale over here. So when I'm going to fix it, the 0 of main scale at point A, right? And one division of a main scale with dot B. So what is the total distance? If we can see clearly, it is exact 3 centimeter. So to measure the length or the distance between these two dots, we are using this normal or a basic instrument, which we call it as a geometry tool, right? So what is the distance or the length between A to B? It is 3 centimeter. Now then, why are we using two different scale? If we can measure the length with this particular scale, then what is the point of using this instrument over here? So my answer to that question is, when we have a linear distance, we can use a meter rule or something like that. But if we want to measure the diameter, let's just say you have this coin and you want to measure its diameter. So it might be some fractional value. It might be what happened over here. If I'm going to put a scale and try to read or try to measure the diameter, is it going to give me the accurate reading over here? You can see it seems or it appears that it is either between 2.4 or 2.5. It's not accurate. So to get the accurate diameter or accurate reading, we have this instrument which we call it as a Vernier Callipers. Now let us understand its different parts and its use. So here you can see this is the knob. I'm going to press the knob upwards, then slide open it. So when I'm going to fix my object in between this two jaw, here as a simple example, I'm taking the pen cap, right? So to measure its outer diameter, we have these two outer jaws, and to measure the inner diameter of a cap, which is its inside part, then at that time we use this two inner jaws. Apart from the outer jaws and inner jaws, Vernier Caliper also has this depth gauge. So what is, either you can call it as a tail or a depth gauge. What is the use of it? If you want to measure the depth of this cap, what you will do? You will press this knob and you try to open the depth gauge, and you need to fix it accordingly over here. In order to measure the depth of this cap, you measure it with depth gauge, which is given over here. So you just open the depth gauge like this, and then you are going to fix it inside the instrument till the time it is going to reach till the end, and that way you can measure the depth of any particular object. And this instrument, let me just say, it's very common. If you have observed the carpenter or any workers who is associated with the civil engineering, they also know how to read it. So in order to learn this with the more precisely, what we can do, we should focus on two different things. One is main scale, another is Vernier scale. So here you can see a Vernier scale which is with the 10 small division, and the main scale over here is same like the scale which you use in your maths class, right? So now here when we are going to talk about what is the use or which way we can get the reading by using this instrument. So let me just try to fix the cap which is available as an object to me for now. So if I'm going to do it, if I'm going to fix it in between two outer jaws, right, what happened over here? You can see there is some change. Initially both the zero were coinciding. When I fix the object in between the jaws, it has slid past. Now in order to get the total diameter or total reading, what can we take? Let me just tell you the formula. The formula to measure the total reading with the help of Vernier caliper is, what will it be? Total reading is equal to MSR plus LC into VSD. Now which VSD? Then you can say coinciding. Now when we say the formula is MSR plus LC into VSD, or you can also write it as a MSR plus VSR. Now this LC stands for least count of the instrument, and coinciding VSD means we will be checking that. What does it mean? So here if you can see, for this particular diameter of a cap which we have taken in consideration, so over here what is happening? Where is the zero? Where is the zero of Vernier scale is coinciding on a main scale, right? So in order to check the main scale reading, you need to focus on zero of Vernier scale. Now zero of Vernier scale is coinciding, or it is in between 1 or 1.1. Can you see? This is the zero. Where it is coinciding on a main scale? In between 1 and 1.1. So always take the previous reading. So if it is in between 1 and 1.1, we will take it as a 1. So what is our main scale reading over here? It will be 1 centimeter, because main scale reading is already in centimeter. Now here what will happen? Centimeter in the sense the distance or the length of 1 unit of a main scale. Length of 1 unit, like 0 to 1 it is 1 centimeter, 1 to 2 is another 1 centimeter, 2 to 3 again 1 centimeter, but the distance between two small division is in millimeter. Similar way, all the Vernier scale divisions, distance between these two is already in millimeter. Coming back to the point, our main scale reading for the diameter of a pen cap is already 1 centimeter. Now over here, if you talk about the Vernier scale division, right? So how to read the Vernier scale? When we said that LC into coinciding VSD. Now when we said that LC into coinciding VSD, what does it mean? Coinciding means out of all the small division of Vernier scale, which one is in the exact alignment with the main scale division? If you can see 0, right, it is not in a straight line. Exact alignment means a straight line with the main scale division. Even division number 1 is not in proper alignment, not even 2, not even 3, 4, 5, not even 6. But if you can see division number 7, it appears little bit here, right? So even that one is not, I cannot take it as a most precise reading. But if I'm going to shift to 8, right? If you can see, it appears straight in the alignment, exact alignment, or even 9. If somebody is going to ask you, let me just try to make it more clear. Out of 8 and 9, which one appears exactly in the alignment? Right? It is number 8. Even number 9 is slightly here and there. It is not most accurate, but I can take division number 8 over here. It is in straight alignment, it is in exact alignment with the main scale, right? So what will be my coinciding VSD? Number 8. So over here in the formula, when we talk about VSR, which is LC into coinciding VSD, our VSR is LC into coinciding VSD. So what is my LC? Least count of vernier caliper is always 0.01 centimeter into coinciding VSD. I hope you remember which one is the coinciding division out of all this small division. It was number 8. So now what will it be finally? 1 plus 0.08. 0.01 into 8, it gives me 0.08. Now here finally, the diameter of a pen cap is going to be 1.08 centimeter. So what is the total reading, or what is the total diameter of this pen cap? It's going to be 1.08. If I'm going to measure the diameter by using a scale, let me just try to do that. If I'm going to put a scale over here, what reading it is giving me? It is giving me somewhat in between. You can see, if you can see it clearly, somewhat in between 1 and 1.1. 1 and 1.1. But what about whether it is exactly 1.1? To get the precise reading, what do we have? This vernier scale over here, right? So now the final diameter with the more or most precise reading for the diameter of a pen cap is what? It is 1.08 centimeter. So this is how we read vernier calipers. It has a main scale and vernier scale. I hope you remember how to read a main scale. You just need to check where the 0 of vernier scale, the 0 of vernier scale is coinciding, or where it is, on which division of a main scale. Like over here it is in between 1 and 1.1. So take the previous value, which is 1. So our main scale reading for the diameter of a pen cap, it has become 1, while the VSR is LC into coinciding VSD. So which division of vernier scale was coinciding? Number 8. Do not forget to check the most accurate and least accurate division, and out of both, take the most accurate. Ignore the least accurate. The correct way of reading the most accurate division on vernier caliper, or especially on vernier scale, is by keeping an instrument at eye level. Keep it straight in front of your eyes, like we did it in the lab, same way. So keep it in front of your eyes and then check for the precise reading. Otherwise, almost all of them, they will appear as if they are already in alignment. But if you look closely, there will be only one division which is giving you most precise or most accurate reading. Take that and then add them together. So total reading is basically main scale reading plus vernier scale reading, right? So this is how you measure the total diameter by using vernier calipers and reading main scale and vernier scale.